In this problem, we are given the following circuit diagram, and we are told the expressions for the steady state voltage and current at the terminals. These are our terminals right here inside our circuit, and then we are given our V of G and our I of G right here, so our voltage and our current. We are asked what is the impedance seen by the source, and we need to write this in rectangular form. When we look at these, we either need to analyze it as cosine or sine. We can't do two separate things. So what I'm going to do is convert this bottom part, the sine part, to cosine. When we draw a graph like this, we know that our sine is going to look something like this. It's going to start down here, and then it's going to wave like this. We know our cosine is going to start up here, and then wave like this. So it's effectively about 90 degrees behind the peak of our sine. If our sine peaks here, and our cosine peaks here, it's about 90 degrees difference. So we can say, when we look at this part, is that when we make this a cosine, we're going to have our 123 degrees minus our 90 degrees. Again, because cosine is 90 degrees behind our sine. So when we rewrite this out, we're going to have a 6 sine 5000 pi t plus, and this part is going to give us a 33 degrees. And that is the new equation. I wrote sine right here. This should be cosine. We just converted it to cosine. But anyways, that is the new equation if we convert it to cosine. Now we are going to look at both of these and derive two things. We're going to get our Vmax and our phase angle right here. When we write this out, we are going to get that our V of G is equal to 300 with our phase angle, and that is going to be 78 degrees. And this will represent this function. Now we are going to look at the bottom part. Our I of G here is going to equal, in front of this we have a 6, so we'll have 6 angle 33 degrees that we found, so this is 33 degrees. Now we want this in resistance, so what we're going to have to do from here is put these over each other. We know voltage over current gives us resistance, so that's what we're going to do. And this is going to be our new equation. To combine both of these, we're going to have to do two separate things. First thing that we're going to want to do is divide this part. We're going to divide 300 by 6. So for the first part, we have 50. And then for the angle parts right here, and for the degrees after our angle, we are going to subtract these. So we're going to have a 78 minus 33. And this is going to give us 45. So we're going to have 45 degrees. Now to calculate z and write it in rectangular form, we are going to have that our z, and then inside of here, we're going to have a parenthesis, and then we're going to have our 50 angle 45 degrees, and we're going to set this equal to, now this is the important part, we're setting this equal to our 50, and then in parentheses is where we're dealing with our angle. We are going to have the cosine comes before sine, of 45 degrees plus j times the sine of our 45 degrees. So this part right here and this part right here are going to be of this angle part right here. The angle goes into our cosine and sine, and then our 50 is out front. Now we can plug this into a calculator. We're going to say our z is equal to, and then before we do this, we want to make sure we are in degrees. That's very important right here because we are dealing with degrees. We're going to have 45 cosine. That's going to give us approximately 0.7. We need to multiply this by 50 because we need to factor in our 50. And this is going to give us approximately 35.36. So for the first part, we have 35.36. Now we're going to look at the second part. We can clear this, and again, in degrees, we have 45 inside of our sine, and this is being multiplied by our 50, and then because it's at 45 degrees, we know that we're going to get 35.36 again. Don't forget the j out front. We're going to have a plus j 35.36, and the units for this is going to be ohms. We did have voltage over current, so it's not that hard to see, but that is going to be the answer for our first part. Now we are going to deal with how much time in microseconds the current is out of phase with our voltage. And this is kind of like lag. You can think about it as lag. We can draw a graph to represent this as well. We know that our initial expression is perfect. It starts at here, and it goes something like this, for example. And this is for 360 degrees all around. Well, this 45 degrees is a little bit off. Just like we had this cosine and sine, they're a little bit differently phased. We're going to have this on a different frequency than our original expression. It's going to be something, just for example, this is not really how it looks, but something like this. And since it's on a different frequency, that means it is out of phase. Since it says with the voltage, use the, even though it's the same for both, use the omega in our voltage to find the period, because this is dealing with seconds, and then see the difference. So we know to find period, we can have our omega equal to 2 pi over t, and then rewriting this, we'll have t is equal to 2 pi, and then our omega for our voltage is 5,000 pi. And if we divide this out, we are going to get 4 times 10 to the negative fourth. And this is at 360 degrees, again, because it's perfect. Now we need to look at our 45 degrees right here. So at 45 degrees, we need to find the time difference. So at 45 degrees, we need to find the time here. Well, if we take our perfect 360 and divide it by our 45, which is the off part, we're going to get 8. So if we divide this, we're going to get 8. What that means is that we can divide this and see what it gives us. So we are going to have our 0.0004, then divide this by 8, and this will give us 0.00005, or 5 times 10 to the negative fifth. And this is going to be in seconds. Now, we want our answer in microseconds, not just in seconds. So we'll have 5 times 10 to the negative fifth seconds times 1 micro, and this is over 10 to the negative sixth. Now, this is going to cancel out with this, and we're just going to have a 10 to the negative first on bottom. If we flip that on top, we're just going to get times 10. So we are going to have 50 microseconds. And that is the answer for this second part. If you want more introduction to circuit analysis or other steady state voltage, there's a playlist and notes for the entire coursework in the description below that'll be very helpful with any of these intro to circuit analysis problems.